Hey, what's up, everyone? We got Tianqin, founder of Pamir AI, with their new Edge AI board. Tell us a little bit about yourself and what is Pamir AI?
Yeah, we're Pamir AI, a team of two very small startup in SF. What we are building is a supercharged Raspberry Pi that can run AI agent locally. So we started last year around August. We started by just squeezing like small language model into small Raspberry Pi in this size, running all fully locally. Right now, the product kind of shift into more mature, more finished product. This is the product we're selling. Um, yeah, but mainly it's focused on running small language model, running AI agents locally on a small computer. Yeah.
Can you tell us a little bit about, with your first board, what were some early success that you were seeing as people were trying out different applications with the V1?
Yeah. So the V1 looks like this. This is the one we created back in our apartment. Then we started by just running like stable diffusion model on there, and it's just people buying it just because it looks cool. That's kind of how we started. Then later on, we met a company called Magical Toy at Studio 45, and they started using our board to build their talking plushie toy. Then later on, some more AI hardware startup in San Francisco started buying just our development board. That's kind of how we start to take off and the selling product. Yeah, from there we started getting more feedbacks on how to improve on the hardware side, which lead us to the better version. Yeah.
And help us understand what were some of the changes you made in V2 versus V1? Give us some of the specs, give us some of the design decisions so we can understand, yeah, why it's made the way it is.
Yeah. So yeah, in the V1, so on this one, the bigger one, like people actually they don't really care about big screen that much. So we made it to a smaller screen. That's one thing. Also, like a language model standalone, a doesn't really do much. Like when we run a 3D model, it can help you turn a LED on and off, but anything more intelligent than that, um, it's not capable of doing those kind of complex tasks. So we started shifting towards building an agent system around it, like how Cursor did and Cloud Code did it. And we actually give it more flexibility on running cloud model. So we're not like fully exclusive on local model. We try to take in. So if a local model can do something, if you give it a cloud model provider, it should be able to do more, right? So in this design, we actually added like LED status bar to show what the agent's doing. Like if it's thinking, it might blink in yellow. If it's waiting for a response, it will blink on green. So it's just giving a better interface for people to interact with AI agent. Yeah.
Yeah, that makes sense. And I think in the last couple of weeks, you guys have been testing the second board with different hardware, like the robot arms, DSLR. Tell us a little bit more about what that connection looks like. So I think for most people who might have heard about Model Context Protocol, which is a standardized way for an LLM to have an endpoint like an API. And for like GitHub, Notion, Stripe, it's pretty obvious on software. It's not that obvious what physical or embodied MCPs look like. So tell us about some of the early successes you received here, because based off of the last 2 weeks, you guys would load the MCP docs, vibe code a connection, and then control something like a DSLR. So tell us a little bit more about those early experiments.
Yeah. So at least for this device, everything is an MCP server. So for example, the screen, screen itself is a screen MCP. So when you prompt the AI agent, doesn't matter it's cursor or block code, they tell you to show something on the screen, it will go fetch the MCP for the screen and display whatever you call it to. They can also have a microphone building and a speaker building, and they are all exposed via MCP, which means so if you tell Claude or Cursor to listen to something, it will go use the microphone to start to listen for a meeting and do transcription with it. Same for speaker. If you tell it to speak something, it will do go use the speaker and use CTS to speak to you. Also, the camera have MCP. You tell the camera to capture something, it will do that. Yeah. For like we did a bunch of MCP control either for the Sony camera or the robot arm. It's all through USB 3.0. So you can treat this USB 3.0 as an MCP as well. So any communication can be done via USB. You can package it into MCP to control physical things. Yeah.
Can you explain a little bit more? We had some questions around like, is this actually happening at like the firmware level? Is it really just like an API endpoint? Talk a little bit more about like maybe for the DSLR example, how is it actually packaged where this dev board is able to actually control the DSLR with Claude?
Could you expand more on like
for people who don't know how MCP works,
yeah.
you just explain a little bit more about how this is able using Claude as a client, how it's to a DSLR?
Yeah. So for any, for example, for the camera, like they already have open source repo. They probably already have some SDK or API given on the GitHub. Once you have that context and you know how to build an MCP, for example, from Claude, they have a well written MCP documentation. So you can just follow this documentation to build MCP. So if the AI agent have all those contexts, they can just translate the existing SDK or API into MCP format. Once you have that, you can run the MCP locally on the device because it's a Linux system. You can just keep it running. And for the client, the client is actually also running on the device. It's using a model provider endpoint through HTTP call. So the client will intake the MCP and the information of the MCP, inject as context into the language model. So the language model knows what's the command to use a camera capture, what's the command to make the robot arm move, given a waypoint as input. Yeah, so once it has all the information, it can kind of work like a workflow. It will call a capture to first, then based on the capture to, it will run another command to either move a robot arm or I don't know, save the image or send the image to someone. I don't know if that makes sense.
Yeah, that does. Appreciate that walkthrough. I think last thing to end on, what are some ideas you'd love to see people build that haven't been built yet with these boards?
Yeah, so I think if you have your own hardware, like a robot arm, you can definitely leverage that because the robot, they have a great open source repo that you can just immediately convert into MCP. You just throw the repo to Cursor and probably write an MCP for you, which you can control while the USB. We accept that we also have like I2C port, also GPIO port. So which means anything that's using the standard I2C protocol. For example, I have this is a air quality sensor. So if I want to build a smart air quality sensor I can just plug the I2C to there, and write MCP to retrieve data and convert the data to like human understandable metrics, and then you call another MCP to display on the display as well. So yeah, so basically any sensor that either use GPL or I2C or USB, you can turn it into a smart AI hardware. Yeah.
Awesome. Cool. Thanks so much for the intro. We're going to wrap it here.
Yeah.